Hello everyone, this is Anthony Richardson, your network analyst here at the Cedarville Independent School District. I want to thank you so much for taking the time to view this film. This is going to be just a short tutorial on networks and powers, and I will show you what I mean by this in a few moments. If you kind of got to go in your head back to some of your math days and in grade school, in high school or whatnot, where we use exponents because those come into play as we deal with networks. And so this particular sheet that I'm referencing that you see here now, I'll make this available to you on the G drive so you can kind of have this as a frame of reference for future purposes and different things you may be wrapped up into. But this sheet you're going to need to be able to memorize and know. Because this is the world of networking, especially when it relates to IP addresses. And so when it comes to troubleshooting devices, whether it be a printer, whether it be a desktop or a laptop or whatever that's getting an IP address or using an IP address to communicate on the network, which is anything that wants to communicate, it's got to have an IP address. Then you are going to need to understand how that IP address relates to its subnet mask and how all of that relates to its default gateway, because if any one of those settings is off, specifically the subnet mask and the default gateway for a particular IP address, if they don't match, then you're not going to have in the networking world what they call layer 3 connectivity to it, which is basically communication by IP address. I'm going to bring another document into view. I can make this available. It's not necessarily necessary. You can just make reference to it in this document. But what you're going to need to know as it relates to an IP address is its increment value, and I'll explain to you in just a moment what that means, what the increment value is, because that's going to help you to determine whether or not a particular IP address is on the same, has the correct default gateway address set for that IP address. So you can't just arbitrarily assign an IP address and just give it some arbitrary default gateway when you expect to communicate, because these have to be on the same network in order for them to be able to communicate out, or for devices to be able to communicate to it. The default gateway tells this particular host, whatever machine this is at this address, this is how you get out to communicate to other devices that are on your network, or get out to communicate to the World Wide Web. So if this machine doesn't have a way of getting out, or doesn't know where this address is that it's getting out to, and it's going to know if this is correct based upon this particular address here of the subnet mask. If this is not set correctly, then this machine cannot communicate out. So you want to have internet connectivity, you want to have email, you want to be able to print, you want to be able to do anything that requires network connectivity. So what does this increment value mean? Well, this chart will show you really briefly what that means. Let me reference this as well, and we'll use, maybe I can put these side by side, and this probably could be a little bit more helpful for us. Let me see if I can reduce this down, move this over, put this here, move this here. I can get rid of this. This kind of give me some more real estate, and expand this out just a little bit so you can kind of see everything side by side. So if you have an IP address, what is the increment value for this particular subnet mask? What you have to do as it relates to the subnet mask is you need to be able to convert that into its binary equivalent. This is what the binary ones and zeros are down here. So basically, for every one, that means on, zeros are off. It means count that particular bit. So in every subnet mask, there's 8 bits that make up this octet of the subnet mask. Okay, and these 8 bits are represented by these ones and zeros that are in this binary equivalent example down below. So for a subnet mask of 255.255.252.0, this is what it looks like in its binary equivalent. What does that mean? Remember back to your power days, remember 2 to the 0, anything raised to the 0 power is going to equal to 1. I might can line these up a little bit more. I may have just moved because I adjusted it. But you kind of get the idea. I don't want to get too far into this formatting phase, but anything raised to the 0 power is going to equal 1. 2 raised to the 1 power is 2. 2 squared is 4, 2 to the cubed is 8, 2 to the 4th power is 16, all the way up to 2 to the 7th power, which is 128. Now, if you count these, this is the reason why I put these down here. These are 8 bits. These 8 bits make up 1 octet in an IP address or a subnet mask. So for an address of 255.255.252.0, that means if you take and add this number, add up all these numbers, you're going to get 255. Basically, that means that every bit is set to a 1, which means that bit is on. Okay, so in this particular case, for this subnet mask, the reason why this 255 is represented by these 1s is because 255 is equivalent to all 1s or all these bits being turned on. Same thing for the second subnet or second octet in that particular device, but the third one's a little different. It's 252. Well, how do we get 252, or how do we represent 252 in its binary equivalent? 252 is represented by turning on the first 6 bits. As you can see here, if you turn on the first bit, it's only going to be 128. If you turn on the first 2 bits, it's going to equal to 192. If you turn on all bits, it's going to equal to 255. If you only turn on 7 of the 8 bits, it's going to equal to 254. But if you only turn on 6 of the bits, you're going to equal to 252. So 252 is represented by 6 1s in that third octet. And that's where you get the 252 represented like this. And then host addresses for a network mask. Host addresses are represented by 0s, and I'll explain that in a minute with these 2 formulas. And then 1s mean they're network addresses, or it relates to the network bit. So these are network bits. They're all the ones that are turned on are network bits. All the ones that are left at 0s are host bits, and they make a difference when we come to this as relates to creating a network space that has enough IP addresses to cover the anticipated amount of hosts, whether they be printers, whether it be access points, laptops, whatever the case may be. You have to scale out and anticipate what you expect to be on your network and be sure that you have enough IP addresses available for that particular level or number of hosts that you need. So going back to our example, we're going to talk about this increment value. So 252. So if you notice, first octet is 255, second octet is 255, the third octet is 252, and the final octet is 0. Well, you have to look to where all of your network bits end. Wherever those network bits end, that's going to give you your increment value. So in other words, you see here that it turns to 0s at this point, and it goes on and finishes out the subnet mask by that. So when you look at this particular third octet, you see at the 6th bit, it starts at the 7th bit rather, it starts at 0s. That is very significant because if you count here to the 6th bit, 1, 2, 3, 4, 5, 6. I put this here just kind of a handy quick reference to the 6th bit. You'll notice that is equivalent to 252, but that's also equivalent to the number 4, which is 2 squared. That's the value of 2 squared, which is equal to 4. That 4 is significant because it means that an address that has a 252 subnet mask, in order to find the different networks that relate to that particular subnet mask, you have to increment the third octet by 4. So for instance, if you have an address space of 10.0.0.0 and you want to subnet this out to make address spaces for, let's say, your high school, and then you also want to create you need an address space for your high school. You also need an address space for your middle school and also for your elementary school. And you're going to subnet this particular address block out, which is a Class A address. Then how you would do that with enough host addresses to be able to have IP addresses for all the devices that you'll have on this network, you have to increment the third octet by 4. So for the high school, you can say, okay, this is going to be the IP address for that particular location. Then you have to increment the third octet by 4. And so the middle school is going to be 10.0. And remember, it's a third octet .4.0. That's what the middle school is going to be. And in order for the elementary school to have a subnet or a space of addresses, you're going to need to change that to 10.0. Add 4 to the previous one before, and it's going to be 8.0. Now, this is where this comes into play as it relates to the default mask. I'm going to make a little space in here because it's going to make a difference. If you have a default gateway, and I set up these two examples up here so you can kind of see this. If you have, this is incorrect, okay, for the default gateway, because the default gateway has to reside within the same network as the actual IP address. So the last address that you can use in this particular space before you get to that 4 is going to be 3.255. Okay, that's going to be the last usable address. Okay, before you get to .4, because each of these octets can go up to 255, and then it goes. And once it reaches 255, then it increments the octet before it by 1. So if you look here, this default gateway is, in this particular example, is incorrect because the IP address is 10.10.4.1, but the default gateway is 10.10.0.1. So 10.10.4.1 is the next network. So it's going to have a default gateway that's on that range. So in order to correct this, if you had a host that wasn't able to communicate, you would be able to go up under ipconfig on your device and just to verify what the settings are. You can see this is the default gateway, this is the IP address. But if you had an example where it pulled up as this, as the IP address, and this as the default gateway, then you would know immediately, oh, this particular host does not have the correct default gateway, and you can go in and change that up under the IP settings, up under the NIC adapter, to be able to make those modifications correctly. So we may do a couple other videos to kind of drive through some more examples of that, but this will give you a great kind of an overview from a 30,000 foot perspective of why this particular address is not set correctly. What you would need to do if you want to set this correctly, your default gateway could be anything that's in between that address space. So it's helpful to know what how many addresses you have that you can get out of a particular address block if you're given one, and a subnet mask, and being able to subnet that out. So when you're subnetting, one of the things you want to do is also put down the last usable address before it actually goes to the next address space, and then this is and then that'll help you to understand whether or not your default gateway is within that space. And then for this particular one, the next address space is going to be 12, right? So 10.0.12.0. So you know this is going to be 10.0.11.255. Oh, I put 222.255. That's your last usable address within that space. The the network address is not usable. This is actually just the network address. The first usable address in the space actually is 10.0.8.1. Okay, and then the last usable is as indicated, and same thing here. 10.0.0.1 is the first usable, and the last usable address is as such. So we'll also go ahead and fill this out, and maybe in our next film we'll talk about this a little bit more. 10.0.4.1 is the first usable, and then the last usable, and then you can kind of see how these addresses actually are utilized and mapped out. I didn't get to it in this particular film. I don't want to make these too long, so there'll be no more than 15 minutes max. But we'll talk about these networks and then host address and how these formulas come into place and come into play rather as you are filming, or I'm filming, but as you're building out networks and address spaces for hosts on your network. So thank you so much for viewing this, and if you have any questions, please be sure to see a member of your network services team. Thanks so much.